Hello everyone, welcome back. Today we are going to look at powers and exponents. This is one of those topics that looks small but shows up everywhere. Once you get it, a lot of math will get easier. So here's our plan for today. First, why even we need powers, then what a power really means. After that, the one pattern that explains the whole topic. We'll see zero and negative exponents. We'll learn scientific notations. We'll practice working out powers, and we will end with a real example and the common mistakes. So take out a pen and paper for taking notes and let's get started. So now let's see why we need powers. Now look at this number on the screen. This is 4 billion. So 4 with 9 zeros. Now imagine writing this again and again. It will take up so much space and you might end up missing one zero, right? We can write it in a short way. We can write it as 4.0 times 10 to the power 9. Now much shorter and a neat way, right? So now look at this number. This is the width of one strand of a DNA. So it's a point with so many zeros and then 2 and 5 meter, right? So it is so difficult to write in this way. So we can write this in a short way. 2.5 times 10 to the power negative 9. So here's the big idea. Power lets us write very big and very small numbers in a small, neat way. That short form has a name. We call it scientific notation. We will build up to it step by step. Okay, now let's see what is power. Look at this number. Here, the number at the bottom is called the base, and this number high up, which is written in a smaller size, is called the exponent. The way we read this number, we either call it 2 to the power 3 or 2 raised to the exponent 3. So what does this number tells us? It tells us how many times to multiply the base by itself, right? So here, if we see 2 to the power 3, so that means the base is 2. So we are multiplying 2 how many times to the exponent, right? So 3 times. Similarly, here 5 to the power 2 will tell us we have to multiply base how many times? 2 times, because the exponent is 2. Here is a nice way to see this. 5 times 5. So basically 5 rows and 5 columns all multiply gives us 25 small squares. So you see, power is not very complicated. It is just repeated multiplication, right? So you just multiply the base. How many times? Those many times is the exponent. I hope you got the idea. Now, I want to show you the most important idea in this whole lesson. It is a simple pattern. Now, look at this table. On the left is the power, in the middle what it expands to, and on the right the value. So 2 to the power 3 expands to 2 times 2 times 2 and the value is 8. Similarly, 2 to the power 2 is 2 times 2 and the value is 4. So watch carefully. Each time we go down one row, the exponent drops by 1. And what happens to the value? If you see 842, so when you go down by one row, the number is divided by 2, which is the base here. So 2 is the base, so you divide it by 2. So 8 divided by 2, you get 4. 4 divided by 2, you get 2. So let's keep going with the same rule. Here, the exponent here drops to 0 because here the value is 1. The exponent drops to 0. And here the value drops to 1 because 2 divided by 2 is 1. Now, as we go down further, the exponent becomes negative because 0 minus 1 is minus 1. And here, with the same pattern, you divide this number by the base, which is 2, and you get 1 by 2. When you go further down, you drop the exponent by 1, so it becomes minus 2, and you divide this number 1 by 2 by 2 to get 1 by 4. So the two most important fact which we learn from this pattern is anything raised to the exponent 0, the value is 1, as you can see here, and the negative exponent can be written as the reciprocal of that number. For example, 2 to the power negative 1 can be written as the reciprocal of 2, which is 1 by 2 or 2 to the power negative 2 can be written as the reciprocal of 1 by 2 to the power 2, which is 1 by 4. I hope this is clear now. Okay, now let's look at the 0 and negative exponents with a letter a for the base. So here, as you can see, a to the power 3 is a times a times a to the power 1 is a to the power 0 is 1. Now this is a special case and we have to remember this. And we have seen earlier in the pattern section that why any number to the power 0 is 1. Now here one thing is important, that a cannot be 0. Let me write it down. Now this is a special case. A cannot be 0 because 0 to the power 0 is undefined in math. I'll make a separate video as to why we cannot divide by 0 or why 0 to the power 0 is undefined. And the next rule is about the negative exponent. To evaluate the negative exponent, you can simply flip it. Or in other terms, any base raised to a negative exponent is the reciprocal of that number. So here you can see a to the power negative 2 is, you can, instead of writing like this, you can write a to the power negative 2 is the reciprocal of a to the power 2. So basically you flip the power of a negative number and make it positive. So basically you flip it and make it positive. Let's see an example. 2 to the power negative 3. If you flip it, let's write it like this. When you flip it, it becomes 2 to the power 3, which is 2 times 2 times 2, which is equal to 1 by 8. Nice and clean, right? Now let us look at the scientific notation. We have briefly looked into this in the introductory section, but now let's look in detail. So as we have learned, scientific notation helps us to write very big numbers or very small numbers in a neat and tidy way. Now, a scientific notation has got two main parts. One is the number, which is always a number between 1 to 10, and the other one is the power of 10. So this number, which is between 1 and 10, is generally referred to as the coefficient. So let us now see how to convert any number in the scientific notations and what are the rules for that. Now, as we know, a scientific notation has always got two parts. One is the number and the other one is the power of 10. Now let's see how we can get it. In this example, if you see this 4 billion with 9 zeros. Now let's assume the decimal point is here. Now in this, the number is 4. So we'll have to move the decimal to the left at this location. So to move this decimal to this location, how many digits are we moving? 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we are moving the decimal to the left by 9 digits. So the power of 10 will be 9, and this number is 4 decimal 0, or just say 4. So this is the scientific representation of this number. Now let's look at another number. Here the number is 25. Now we cannot write 25.0 because the number has to be between 1 and 10. So we can bring the decimal point between 2 and 5, so it becomes 2.5, right? And how many digits are we moving this decimal? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, we are moving this decimal by 9 digits. So the power becomes 9. But since we are moving the decimal to the right, the power becomes the negative number. So in this case, when we are moving the decimal to the left, the power is positive. When we are moving the decimal to the right, the power is negative. Let's look at this example. So here the number is 479. So where can we put the decimal place so that the number is between 1 and 10? So you can see we'll have to put the decimal place here, right? And how many digits are we moving the decimal? So here if we count 1, 2, 3, 4, 5. So we are moving the decimal by 5 digits. And since we are moving it to the left, the power is positive. So this becomes 4.79 times 10 to the power 5. Now in this example, the number is 5689, right? And we have to move the decimal at this place so that this number becomes between 1 and 10. And how many digits are we moving this decimal place? We are moving 1, 2, 3, 3 digits, and we are moving it to the right. So the power becomes a negative number. I hope this is clear now, and you'll be able to represent any number into scientific notation from here on. And there should not be any confusion. Let us now see through some examples how to evaluate the powers. Two things to watch out for is the sign and the bracket, because they will change the answer. Now here, the minus sign is outside the bracket. Generally, when there is no bracket and the negative sign is there, it means that this negative sign is applied to the whole number, right, including the power. So the other way of writing with bracket is negative of 2 to the power 4. So here you are multiplying 2 4 times to itself because the power is 4 and the answer you get is 16. But because of this negative sign, the answer becomes negative 16. Now let's see here, the negative sign is applied to the base, right? So it's not to the whole number, including the base in the exponent as in the other case, but here the negative sign is applied to the base. Now negative 4 to the power 4 is, you have to multiply negative 4 times to itself, right? That's the definition of power. Now since you multiply negative 4 times, which is an even number, you get a positive answer, right? And 4 into 4 into 4 into 4 gives you 256. Now let's see how this applies to fractions. Now 1 over 3 square or to the power 2 is basically 1 over 3 times 1 over 3, right? Which gives you 1 over 9. So the other way to interpret this is whenever there is an exponent to a fraction, say for example, let's consider 2 over 3. So here you can apply the exponent to both the numerator and denominator separately. You can say 2 to the power 2 and 3 to the power 2, which will give you 4 by 9. Now, you will also see the exponents in formulas, like here the formula for the volume of a cube is side raised to the power 3. So in this case, if the side is 12.5 raised to the power 3, which gives you 1953.1 cubic centimeter. Now, one thing to notice is the negative sign. If the base is a negative, the exponent will determine whether the result will have a negative sign or not, right? So if the exponent is an even number, your result will be positive. If the exponent is odd number, the result will be negative. So let's look at a quick example here. If say we have minus 3 to the power 3, in this case the power is odd number and the result for this will be negative 27. Whereas if you have negative 3 applied twice, which is an even number, the result will be 9. So I hope this clarifies your doubts. Now let's look at a real world example. How do scientists measure things as tiny as DNA and as huge as the sun using the same simple tool? The answer is powers of 10. Now watch this line. The left side we have 10 to the power minus 9 and right side we have 10 to the power 9. Now let's travel along this line. Way down here is the strand of DNA, and as we move along at around 10 to the power minus 5 is a tiny living cell, and near about 10 to the power 0 is you, the human beings, and as we move along 10 to the power 3 is huge mountain, and 10 to the power 7 the size of the earth, and 10 to the power 9 is the sun. Look how far we have traveled. One single line of powers of 10 covers a strand of DNA all the way up to the sun. That is the power of this idea. Now let us see some of the pitfalls related to powers. So the first one is negative 2 to the power 4 equal to 16. Now this is very common mistake to make because here there is no bracket. So you first do the power and then apply the negative sign. So then in this case, the negative sign stays as is because you just do the power calculation and then apply the negative sign. The next very common mistake is 2 to the power 0 is 0. As we have seen from the pattern section, anything raised to the power 0 is always equal to 1, where a is not a 0. The third one is 2 to the power negative 1 equal to negative 2. Now we have seen that whenever there is a negative exponent, you just flip it, right? So this will be 1 by 2. Now, in this case, this is basically an incorrect scientific notation because we have seen that the number part of the scientific notation is always a number between 1 to 10, right? In this case, it is 23 by 7. So the correct way to write this will be 2.37 times 10 to the power 6. Slow down on the sign and brackets and you will get this right every time. Now, let us put it all together. A power is base raised to an exponent. It just means repeated multiplying. The pattern, the big idea, when the exponent drops by 1, you divide the value by the base. That one idea explains everything. From it, any base to the 0 is 1, and a negative exponent flips the number. So if you have a to the power negative n, you will flip it and you will write a to the power positive n. Scientific notations writes number a times 10 to the power n. There is a 10 to the power n, where a is a number between 1 to 10. And when you work with powers, always watch the sign in the brackets. Great work today. Practice a few on your own. In the next lesson, we'll learn the exponent laws, how to multiply powers, divide them, and take a power of a power. See you there.